Hi all, this is Shweta Reddy A, working as Assistant Professor in the Department of Electronics and Communication Engineering from R.M.K College of Engineering and Technology. So let us see the continuation part which we have seen in the previous video, that is applications of restrictions to Maxwell's equation. So if you didn't see the part 1 of this topic, so please do watch that and come so that you'll able to understand. So similarly, I'm going to take this y derivative as 0 here. I'm going to write the seventh equation again. Wherever seventh equation I have written it again. And now I'm going to substitute the 8th, 9th and 10th equation in this 20th equation. This is 20th equation. I'm going to just substitute and obtain this it as 21. Now we are going to solve four things here. One is hx, hy and ex and ey. So to solve this hx, I'm going to write this 14th equation again. From this 14th equation, I'm going to take this ey alone in the LHS, and whatever I have the remaining things, I'm going to write it in the RHS side. So I'm going to just simplify this equation. That is, I'm going to take minus 1 by j omega e alone, and whatever things I have, I'm going to write it inside the brackets. And after that, I'm going to take this minus and minus common outside. So I'll be having ey is equal to minus 1 by j omega epsilon and the remaining equation, and I'm going to mark this equation as 22nd equation. Now I'm going to write the 17th equation which I have got again, which I have got previously, and just now we have got this hx, and that is 23rd equation. I'm going to write it again. Again. So I'm going to substitute this 22nd equation which I have obtained previously in the recent, that is 23rd equation. So in the 23rd equation, if I substitute, I'll be getting like this. And after that, what I'm going to do here is I have this term and this term, right? I'm going to just multiply these both the terms and write this equation. And after that, I'm going to just substitute the value of j square is equal to minus 1 and write this equation. And after that, what I'm going to do here is I'm going to take this inside the brackets for first and for this also, and write this equation. Then what I'm going to do here is I'm going to take this to the LHS side and write the remaining equations. And after that, I have here also I have hx, and here also I have hx. So I'm taking hx common and writing the equation again. And after that, what I'm going to do here is I'm going to take LCM. So if I take LCM, I'll be getting omega square mu epsilon plus gamma square by omega square mu epsilon, and the remaining equation I'm writing it as such. And after that, what I'm doing here is I'm going to cancel this term and this term. So if I cancel this term and I want hx alone, I can take this to the denominator here, and I got the hx equation. I hope you understood. And now instead of gamma square plus omega square mu epsilon, I'm going to replace it by h square. So in the previous equation, we here in this place we had gamma square plus omega square mu epsilon. So I'm going to just replace it by h square and write the 23rd equation. So we have completed solving hx. Now we are going to similarly solve hy. So I'm going to write the 18th equation again. From this 18th equation, I'm going to just take this hy in the left hand side, and remaining terms I'm going to write it in the right hand side. And after that, what I'm going to do here is I'm going to just take this minus and minus common outside and write this 25th equation. Now I have taken this 13th equation which we have obtained previously, and we have this ex equation also. Ex is equal to gamma hy by j omega epsilon. I'm going to mark this as 26th equation. Now what I'm going to do here is from here only we have taken this ex. Ex alone I'm going to keep this side, and the remaining terms I'm going to write it in the right hand side. And after that, I'm going to substitute this 26th equation in 25th equation. I'll be getting this equation. And after that, what I'm going to do here is I'm going to multiply this 1 by j omega mu inside each and every term. So I'll be getting this equation. And after that, what I'm going to do here is I'm going to replace j square by minus 1 and writing the remaining equation as such. And in the previous equation, we this term we had in the right hand side, so I'm just bringing it to the left hand side. And after that, I have hy and hy. I'm going to take it common and write this equation. And after that, what I'm doing here is I'm taking LCM. These steps and all which were same process you are going to repeat. I'm going to take LCM and write the equation similarly. And after that, I'm going to can you in the previous step, in the previous thing, while we are solving hx, we have assumed h square is equal to gamma square plus omega square mu epsilon. Similarly, you're going to assume here also. So hy into this is nothing but h square. Numerator part is nothing but h square, and denominator part you're going to cancel one omega and one omega here, and you have mu also will get cancelled, and the remaining you'll be having omega into epsilon. And in the right hand side, you'll be having 1 by j gamma into Ez, I mean dou Ez by dou x. So this is not just simplification. I hope you understood. And after that, instead of 1 by j, I can replace it by minus j. So if I replace this equation, I'll be getting this 27th equation as hy is equal to minus j omega epsilon by h square into dou Ez by dou x. I hope this is how we have to solve hy. So we have solved hx and hy. I hope you understood. The next thing we have to solve is ex. So in order to solve ex, we are going to write the 13th equation again. After that, from this 13th equation, I'm going to have this hy alone in the LHS side and going to write the remaining terms in the RHS side and write this as 28th equation. So now I'm going to write this 18th equation again and mark it as 29th equation. So now what I'm going to do here is I'm going to substitute this 28 in 29. So now here what I'm going to do here is after substituting you will be getting this equation. So I'm going to just interchange this here and interchange and bring it which I have in the right hand side, I'm going to bring to the left hand side, and which I have in left hand side, I'm going to bring it in the right hand side, and I'll be getting this equation. And after that, what I'm going to do here is just replace this j square as minus 1 and writing this equation. After that, I have ex here and ex here. I'm going to just take it common and write this equation. And after that, I'm going to take LCM, which same thing, same process you're going to repeat, and LCM and writing the equation as such. And after that, can you see we have substituted instead of h square, I'm going to substitute gamma square plus omega square mu epsilon. So same thing you are going to substitute, and after simplification you will be getting ex is equal to minus gamma by h square dou ez by dou x. Next we are going to solve ey. So now we are going to solve EY. In order to solve EY, I'm going to write this 14th equation again and mark it as 31st equation. And I'm going to write the 17th equation again. And after that, in 17th equation, I'm going to take this hx alone in the left hand side and remaining terms in the right hand side and marking it as 32nd equation. After that, I'm going to substitute this 32nd equation in 31st equation. After substituting, you'll be getting this. And after that, what I'm going to do here, here is just multiply this gamma inside. So if I multiply, I'll be getting like this. And after that, I'm going to just take this part which I have in RHS to the LHS side, and this LHS I am going to take to the RHS side. So I'll be getting this equation. I have EY here and I also have EY here. So I'm just taking common, and similarly after simplification, you will be just replacing h square is equal to gamma square plus omega square mu epsilon. So after substituting h square, you will be getting this equation. And finally, Ey equation is nothing but j omega mu by h square into dou hz by dou x. So you have solved Ex equation, which you have obtained as minus gamma by h square dou Ez by dou x, and Ey equation you got it as j omega mu by h square dou hz by dou x, and hx equation as minus gamma by h square dou hz by dou x, and hy equation as minus j omega epsilon by h square dou Ez by dou x. I hope you understood. And here we have three cases. Case 1 is nothing but if Ez is present and Hz is 0, we will be calling it as transverse magnetic wave or TM wave or E wave also we can call. Next, if Hz is present and Ez is 0, we will be calling that equation as transverse electric wave or TE wave or H waves. And in another case, if the wave does not contain Ez nor Hz, then we will be calling it as transverse electromagnetic waves or TEM waves. I hope you understood. Thank you all.